Let us solve the last problem in this chapter. This is problem number 5. Okay. So we're still ang topic natin is most efficient cross section And last problem, determine the maximum flow through a 1.2 meters diameter concrete culvert which is laid on a slope of 0.009. Use roughness coefficient of 0.013. I have made a video, actually that's why nasulatan natin ito. I have made a video pero nakat. I was planning to continue with it pero ito na lang. I have made a separate video na lang para may continuity yung discussion. So, hindi siya nakat. Okay. So, kaya may sulat na yung ating paper here. But anyway, let's just forget about it, then continue with this problem. So for circular sections, the discharge Q or the flow rate is maximum when the depth of flow is 93.8% of the diameter. Okay? So if that is the case, multiply lang natin yung 0.938 and the diameter, that would be would give us the depth required for the flow to be maximum. So we're solving for the flow discharge using Manning's formula. Okay, so using Manning's formula, we need to solve for the following items: the area of flow and then the hydraulic radius. Again, we need to solve for the area of flow and then the hydraulic radius to solve for the discharge. Since given naman na yung slope and then the roughness coefficient n. So to solve for the area, we can solve for the area using different methods, but for our discussion we're just going to use one, right? So we can divide it into two sections, since although this is a circular segment, the entire area is a circular segment. You can directly solve for the area using a certain formula for circular area for circular segments. But in this case, we're just going to divide it into two sections, one a sector and a triangle. Okay, a sector and a triangle. Ito. Okay, yung sector na shade siya ng dots. And then yung triangle naka-shade ng paslant. Okay, diagonal lines then. Okay. So to solve for the area of a triangle, we have several formulas to solve for the area of a triangle, but we're going to use just one in this particular problem. And then area of a sector, we can also solve for the area of a sector if we know the central angle theta here and the two sides. Then we can definitely solve for the area of a sector. So triangle, if we know the base and then the height of the triangle, then we can solve for the area of a triangle. Another way to solve for the area of a triangle is if we know the central angle here. So if this is angle beta, okay, if this is angle beta, 2 beta, if we know this angle, yung buong yan, and then we know the include adjacent sides of the triangle, then we can solve the area of a triangle without solving the without solving the base, I should say, of the triangle. Okay, so the total area then is the sum of the area of the sector and the area of the triangle. Okay, so let's first solve for the area of the triangle. So the area of a triangle is equivalent to given yung angle natin dito, angle, that is 1 of r squared sine of, dapat twice ng angle natin dito. That should be sine of 2 beta. Twice ng angle beta natin. Yan. Para ma-solve natin yung buong area ng triangle na ito. Okay? So that's the area of the triangle. Okay, so let's just try to solve for the area of a triangle. But first, we need to solve for the angle beta. Ito. How do we solve for the angle beta? So we know this side is the radius of the circle. And yung radius niya. So give it's 0.6. The diameter is 1.2. So definitely the radius is 0.6 of a meter. Now we need another given here na para ma-solve natin yung angle beta. Maybe we can solve for this side or this side of the triangle. I think it would be easier to solve for this side of the triangle, the adjacent side. So h, how do you solve for h? So h, I hope this is still visible. H is equal to, so how do you solve for h? If we know this length, this is 1.1256 meters, then we can solve for h. No, that's 1256 meters minus the radius. And that would give us the value of h now. So that is 1.1256 meters minus the radius, which is 0.6 of a meter. Then the height of the triangle is, what's the height of the triangle? 0.5256 meters. That's the height of the triangle. So alam na natin yung dalawang sides. Ito, hypotenuse. And then the adjacent side here. Now we can now solve for the angle beta since right triangle naman ito. Okay? So cosine ba? Kasi adjacent side eh. So since adjacent side naman yung given and we're solving for the angle beta, so we use the cosine function. So cosine of the angle beta is equal to adjacent, which is h, which is 0.5256 over the hypotenuse, which is 0.6. So the angle beta is equal to, so what's the angle beta? 28.84 degrees. Okay, it's the angle beta. Okay, next is what is twice of beta here? What is twice of beta? Para ma-solve na natin yung area ng triangle. So twice of beta, that's just 2 times 28.84 degrees. That's equivalent to 57.68 degrees. That's twice of beta, which will be used later on to solve for the area of a triangle. Next, let us solve for the angle theta so that we can solve also for the area of the sector. So how do you solve for the angle theta? If we know this angle twice of beta, then angle theta is simply equal to the total that's 360 degrees, no, minus angle ito, this angle, that would give us the angle, the value of the angle theta. So angle theta is equal to 360 degrees minus yung buong angle na to, that is 57.68 degrees. So angle theta is 302.32 degrees. So we already know angle theta twice of beta. Then we can now solve for the areas of the sector and the triangle. So first, let us solve for the area of the triangle. Area of a triangle is equal to 1/2 times the radius r squared. Since ito yung adjacent sides, ano? Ito yung adjacent sides natin. And given yung included angle natin. So the adjacent sides is 0.6 sine of the angle twice of beta. Ito. That is 57.68 degrees. So the area of the triangle is equal to, so the area of the triangle is equal to 0.15 square meters. Okay. And then we solve for the area of the sector. So how do you solve for the area of the sector? Area ng sector is equal to 1/2 r squared theta. And theta here should be in radians. So 1/2 r squared theta, theta should be in radians. Oh, by the way, baka nagtatanong kayo, saan ba nanggaling yung formula kanina na area ng triangle, that's 1/2 r squared sine of the included angle. Originally, that is area ng triangle is equal to 1/2 AB. AB sine of any angle here, theta. So AB, kapag given kasi yung two sides and then included angle, you can solve directly for the area of a triangle, no? Nagkataon na yung radius natin dito, yung adjacent sides ay parehas na radius. So that is simply area ng triangle would be 1/2 r squared, no? So r times r. Ang A natin is r, B natin is r, no? So it will give us r squared. So 1/2 r squared sine of the included angle, okay? Which is 57.68 degrees. Okay. So the area of the sector is equal to, so you have 1/2, sa kabilang page na lang. Let's use another page for the succeeding parts of the solution. Okay. So area ng sector is equal to 1/2 r squared theta in radians. So area ng sector then is equal to 1/2. The radius is 0.6 squared times theta in radians. So ang given na angle theta natin is in degrees. We convert that to radians. So ang theta natin is 302.32 degrees. Convert natin sa radians. How do you convert that to radians? You multiply it by pi over 180 degrees. Okay. So the area of the sector then is equal to 0.95 square meters. So the total area of, or that the area of flow is equal to area ng triangle plus area ng sector. So that is 0.15 square meters plus 0.95 square meters. So that would give us an area of 1.1 square meters. Okay, so we're done solving for the area. Now let's solve for the hydraulic radius. So hydraulic radius is the ratio of the area of flow and then the wetted perimeter. Oh no, nag-blurred siya. Okay. So the hydraulic radius is equal to area over the wetted perimeter. So remember, let's try to go back. Ang wetted perimeter natin ay dito. Ito lang yung wetted perimeter natin. Hindi kasali ito Ito lang. This is our wetted perimeter. Hanggang dyan lang. So how do you solve for the wetted perimeter? So the wetted perimeter, so let's just, para may illustration tayo. So the wetted perimeter is equal to, so length ng arc ng circle. How do you solve for the length of an arc of a circle? So let's say, denote that as P ng sector. Length ng arc ng sector natin. That is equal to r theta in radians. Okay. R yung radius natin times the angle, it should be in radians. Okay. So if that is the case, the perimeter of the sector is equal to, we have 0.6 times, again we convert the angle theta in radians. So 302.32 degrees times pi over 180 degrees. So the perimeter of the sector, the weighted perimeter, is equal to 3.17 meters. So, okay, compute na tayo. We already have the area. We can now compute for the hydraulic radius since we have the area and the perimeter. So we can now compute for the discharge now. So Q is equal to A over N. A is 1.1 square meters divided by N, which is 0.013, times the hydraulic radius area over wetted perimeter, that is 1.1 square meters divided by 3.17 meters raised to 2/3 S raised to 1/2. So 0.009 raised to 1/2. So that would give us a flow rate of 3.96 cubic meters per second. So that would be the maximum discharge in the culvert. Okay, so that's it. So we'll proceed to the next chapter next week na siguro. Okay.